Really excited to welcome our guest lecturer from Joel Hutchines, who is the founder of Splash Modular and their Revea platform. But he might give some updates around the latest there. He was just telling me he's going to walk us through kind of his career journey in entrepreneurship for industrialized construction for complex product configuration. So I won't say too much, Joel. I'll let you go from there, and feel free to get started, share your screen, whatever you'd like to do. And we're really glad to have you. So
great, thank you. I appreciate you having me here. And let me just share my screen. Can we see that okay?
I've got the PowerPoint, and let's see. Now I've got full screen. Perfect.
Perfect. Okay, so I'll kick off. Thanks for the introduction, Daniel. My name is Joel Hutchines. I am the CEO of Splash Modular, so founder and CEO until about 2 weeks ago, and I'll touch on that at the end of the presentation. But we've had some big news, and we've been acquired in the last few weeks. So today I'm really going to walk you through my career path from carpentry, entrepreneur, all the way through architect. And really with the idea and the common theme here of configurators, kits of parts, and mass customization. So we'll kick off straight away with a bit of the past. I started my career in carpentry. Carpentry here in Australia is very hands-on, out in the sun, framing, stick building houses conventionally. I did my time there in the volume building era, or the volume building sector here in Australia, where we would produce the same house multiple times, and we would frame it on the floor, on the slab, stand it up, and get sunburnt every day. From there, my drive sort of led me down to the idea that I wanted to get more into the building. I wanted to get more into the management side, the builder or the general contractor, and really looking at construction from that administration side and running projects that way. That opened my eyes a lot into the whole process of building mainly residential houses, but we did do a few different sort of projects as well. From there, I enrolled in architecture school. I decided to go back to school, and I wanted to really look at the process from design all the way through. I didn't really, although my mum was an artist and I grew up with a creative household, I didn't really come into architecture from that creative side. I came into it from a process side. I came into wanting to understand more and control more of the process, with the dream that I would design a couple of houses a year, and I would take them all the way through building them, and through the whole process. And that was really the dream. I saw myself sort of living that life of surfing every day and doing that. And funnily enough, it was sort of after I finished my bachelor degree, I took off to Tokyo. I got a job at Shigeru Ban in Tokyo, and that changed everything. That was really when I guess the entrepreneurial side was sort of jumped in, but the drive for much more. I learned computational design, and I learned scripting whilst I was at school, mainly in Grasshopper. But when I got to Tokyo and to Shigeru Ban, and I was working with Arab engineering firms and the like, I really saw a skill set there, coming from building, but then knowing computational design. I understood the process, and I understood how to break down that process and then automate it. And that really drove me to the next level with Shigeru Ban in terms of digital fabrication. So I had this process. I knew how to computational design. I knew how to design to actually build things rather than just sort of lines on paper. And through my architectural education, I guess that was something that really bugged me. Whenever I had a group project and I went into a group project with people that just wanted to design and just wanted it to look pretty, and I would get extremely frustrated saying, come on guys, we need to make this buildable, probably to the detriment of my architectural education, but nonetheless, it was a very interesting process to then find myself with Shigeru Ban, knowing computational design and digital fabrication. It really opened up my eyes to the possibilities. From there, I as I just explained, I became a DFMA specialist, and I guess I turned myself that mainly because of this career path. As I undertook this career path, I understood that you had to design things to that level to then gain that efficiency. And then I knew that if I actually leverage computational design and digital fabrication, I could control much more of the process. So after working in Tokyo for Shigeru Ban, I returned back to Australia and started Studio Workshop. Studio Workshop was, we started off as design, but we very quickly turned into fabrication when we bought CNC routers and we set up our own factory. And then, given my experience, we decided, look, let's take the build as well. Let's just go end to end with this, the entire process, and we'll control it. Now, we started testing some ideas with furniture, and the idea that if we designed it through computational design and then we fabricated it, that we could completely automate the process and have minimal touch points for the human in the middle. And we started to play around with ideas in shop fits. We started to look at the shop fitting sector, where it was hugely profitable for us to do that. Mainly, the one thing that we did realize, though, that in doing this is that we had to absorb the cost of the design. We could take the design to a very high level of detail, but no one was willing to pay us for that. And so that was mainly why we ended up taking the build, is that we could then recoup all the costs and we were a lot more profitable by taking the complete end-to-end process. One thing we didn't account for is that as a design firm and contractually, we learned some hard lessons that designing it to that level, if we lost the project before we got to the fabrication and build, we were in the red. So although we became hugely profitable and made some great money on some projects, on other projects, we really lost a lot. And it was a great struggle through Studio Workshop's evolution to consistently be a profitable business with that in mind. So one area we did sit was really in between architect and builder. We ended up leveraging those skills to resolve complex structures and kits of parts. But when we were lucky enough to take the entire project, we got to do some cool stuff. So this project here in Papua New Guinea, we had the complete design, the build, the fabrication. So this was a really interesting project where although we got to design it, we had to design the process in its entirety. It was in Papua New Guinea, we had no skilled labor, and yet we wanted to create something like this. So we kept the structure very basic with the off-form concrete here, and we leveraged the local skill that we could find to do that. Albeit that we did have to fly some skilled labor to lead that local unskilled labor up there, and but we built that concrete shell. And then the main element here that you're seeing is this curvy, wavy timber structure. And that was a common theme at Studio Workshop, is that we leveraged timber. We didn't really start to explore too much outside of what we knew well and what we could achieve with the CNC router. But this was really where we started to really break out from a lot of what we did was sheet material. We had a CNC router, we understood sheet material, that we could cut it and we could create those structures, but this was a breakout to an extreme with the process. So I want to walk you through the process here a little bit more. And that was where, this is where, you know, to an extreme we took it, but we knew that we could design a process that was possibly replicatable. We could never foresee many houses having curvy, wavy timber facades like this. It was a little bit extreme, but the process we could utilize. So step one for us was breaking it right the way down to the actual curvature in the surface. So on the top left-hand side there in the green, you can see that where we built the script so we could adjust and we could have real-time adjustment of that surface. Many reasons why we wanted to do that. We wanted to look at, that was really the customization element, but I'll touch on where we took that curvature to another level in a second. The next step was that we broke that down into contours. We essentially contoured it down, but then started to break down it into the elements with the curvature. So rather than just contouring it, we had to break down where we had that ridge line in the curve, we had to make a joint there. From there, we had to really look at the joint, and we had to think about, when we were making that joint, how do we ensure that it comes together at the perfect angle. We had to look at what we could do on the CNC router to ensure that the guys in the factory, you know, I love them, but they were unskilled. We had laborers essentially in our factory. How would they put it together and consistently put it in the right spot? And then the last step there was breaking that into panels for shipping. So then take that back. That was what ended up informing the curvature of the surface. We had to fit this in one shipping container. So we had to look at how we could nest it in real time and place it, so package it into the container, and that would drive the curvature of the form, which would then go through the whole process to do that. Now down the bottom there, you see the process of fabrication. That had to come into it as well. So we had to look at how we build a jig. The jig would hold the members of the timber. That would go into the CNC. And then the little pink elements in there is how we design the joint. So when we actually end up putting a biscuit, a little timber biscuit rather than a dowel, so that timber biscuit had no movement and it would always go together in the right section. So this is one area one project that we really took that process to an extreme. But throughout our process, in some more images here, you can see on the top those sticks to those members to being assembled to the panels, and then the panels being installed. Once again, we even had to take it to an extreme with the installation being unskilled labor and how they would be placed up there. So we had to go for a lighter weight timber, but then something that would endure the environment in Papua New Guinea. So there was a whole process. We really had to control the whole thing. Now, this was something that we took, an approach that we took through all of our projects at Studio Workshop. You can see there some of the shop fits and some of those on the bottom there with the curvy wavy timber. The process that we took a little bit further is we actually wrote into the script for efficiency. So the back of one sheet would become the front of the other. We started to look at sheet efficiency and material efficiency. To the light show here and under the Sydney Harbour Bridge, that was something where we took HDPE and it was sheets, and we did that with the university. And then right the way through to, I guess, a project that won international design awards, but on the left-hand side there, a townhouse project. And that was a development that we did ourselves. And we learned some harsh lessons in terms of controlling the whole process and the financial side. But nonetheless, it was, again, it exemplified our process-driven approach. Now, through all of this and the curvy, wavy timbers and the shop fits, one thing that really drove me crazy as a director of this business is that we never really applied it to just industrialized construction or into not curvy, wavy facades or this sort of what is coined parametric design a lot of the time. Or, you know, if you Google parametric design, you end up with a lot of these type of projects on the put to the forefront. But I wanted to push that and explore how we could take that to an extreme with standard elements. It was really then in a response to the process of construction and pre-construction that we started to develop a new business model, or that I started to develop a new business model. I was sick of this front-end collaboration in 3D representation or in BIM, and this process of back and forth between all the stakeholders to then essentially boil it down to a 2D representation. I was completely, I ended up consulting to a general contractor in Australia who wanted to establish a bathroom production line. But all through this process, you can see down here, the automated machinery right down the process, that they were bringing in the bathroom pod. And when they were bringing in the bathroom pod and the supply chain's great machinery, whether it was a light gauge steel framing machine or anything, it had been passed through so many hands and the data had been interpreted, it had been value engineered, that there was this complete inefficiency and lack of data flow between all the stakeholders. What I did realize is that all of these suppliers and this CAD/CAM process and all these kit of parts and subcontractors, they needed to be involved early in this process. They needed to be down here rather than the modular consultant. They needed to actually be involved in that design. But as we'd learned through that process is if we spend too much time as a supply chain or as a fabricator up that front end, we lose out because we're not always used in that design, or the fact that we were gifting our IP to people. We were telling them how to design so that they could go down the road and use our competitors. And that really struck a chord with me, and I wanted to think about this entire pre-construction process and figure out how we could change it. So I packed my bags and I spotted a market, a hole in the market in North America for bathroom pods. There was 20 something manufacturers for bathroom pods in Australia at that time, and only real 3 competitors in North America. Much larger market, and a huge opportunity. So we took the idea of a bathroom pod as a physical product. There was a lot of modular construction companies at this time, and there still is today, preaching that they created a product. They designed this new way of building it, which really 90% of the time isn't really any new way, but they designed this new way of building something. So we and called it a product. We decided that we'd create a product, but our product would be based around a kit of parts. That we would design a bathroom where we could find a supply chain that was embracing digital fabrication or any machinery in that case, and we could create a kit of parts. So we could design a bathroom based off of these elements that would easily come together. And then those elements had to be digitally fabricated. We had to look at the entire process and understand how it was actually built. And then we could build an algorithm. We could build a script that designed that bathroom and designed that kit of parts and ran that supply chain. So an example here is the light gauge steel framing. It had to be a light gauge steel framing from one machine. So we understood that how to actually take it or design for that machine. And then we had the drywall or the sheetrock or the plasterboard, whatever you want to call it. We actually had to find a different type of plasterboard that was moisture resistant, but it could also be CNC cut. And we had to find a network of fabricators that had the CNC machine capable of doing that. So we took it all the way, established relationships with the complete supply chain, but also started to build an algorithm where we could understand what are the constraints of all those supply items or those supplies as well. We understood that the drywall, the sheet size, we knew the sheet size of that. So we had to build that in because that would dictate the extremes of which we could take the design. We had to understand the shipping of each component and develop the process for that shipping so that we could control and understand what was actually achievable. Now, when we understood all of that, that's what we believe mass customization to be, designing within the realm of what is actually achievable. Too often do I hear people referring to mass customization as completely bespoke or completely bespoke with the intention of design, or with design intent. So it was lines on paper, kick the can down the road and someone else will figure it out, which is normal construction, majority of construction. So we packaged it the other way. We took the process, we understood what was achievable with our supply chain materials, and we built it into an algorithm. Now that algorithm automated the entire process, as I said, but allowed us to start to leverage localized assembly. The whole business model here was that we would not build the bathrooms. We would become the largest fabricator of modular bathrooms in North America without actually physically building anything. So what we did was we licensed the assembly. We developed an assembly line process, and we licensed that out to other manufacturers. And then we leveraged that supply chain and that kit of parts to have that show up, and then unskilled labor could put that together. So we were a hugely productive assembly line instantly off the bat because we designed things to not only be fabricated or digitally fabricated, but we designed the process of how it came together. So we actually started building bathrooms. We built hundreds of bathrooms in the first few months. And we made 2.5% of the bathroom pod. So we actually made a construction value, and which is rare in that process to be able to do that. We made 2.5% on every bathroom built, and we were able to drive innovation. We were able to take that algorithm and that automated process and better it. We quickly learned every process, every bathroom that we saw come down the line. We saw that, the problems, and we put them into the algorithm. We put them into the process, and we made sure that we would never make the same mistake twice. that became hugely beneficial because now all of a sudden we were inventing new ways of building bathroom pods and all this IP around there, but also controlling our supply chain's infrastructure without us actually owning them. Now that became a very different and I guess controversial way of looking at it compared to the vertically integrated models that we were seeing driving the industry forward. But ironically, it was the vertically integrated construction companies. So this was Splash Modular. It was the vertically integrated construction companies that started coming to us and saying, hey, how do we do the same thing, right? We can't get a bill of materials out of our BIM right now. We can't do these simple things, yet you're driving this whole supply chain and this huge efficiency and automating the entire process and having data, two-directional data flow. How do we do this? So that was where we patented the idea of the CDP, the customizable digital product, or the object.cdp, because we ended up calling it its own file type. But essentially what that was, it was a script that understood its supply chain. So by linking a computational design or a computational script to the direct supply chain, we could load that script with manufacturing constraints and efficiencies, logistics, supply chains, engineering. We could load it with as much information specific to that supply chain or that group as possible. And then we could automate the output. The whole entire process was automated and you could spit out machinery code directly. BOM was not a problem. Automatic shop drawings. That was probably the biggest value proposition that we saw, or the biggest uptake was what you can automate shop drawings. They didn't really care for the machinery files. They were just stoked that we could automate that entire process for them. So we figured that we would go out and market that. We'd market that idea of inputs and outputs. Majority of our process there, or that process, and this was really all happening last year, late 2019 all the way through 2020. So we were contending with COVID as well, and the fact that nobody really wanted to spend money, but they all had this process. They wanted to out of the firing with once COVID was over with a better process, because one thing it did highlight to all of them is there's a better way to do it. So this proof of the concept really was the bathroom pod. The main elements there, you can see the CDP is, as I described, the steel framing, the sheetrock, those vanities, those elements. We created a service box, we called it, and we designed everything so that we could, all of the MEP essentially that would run it, we could put into one box, and that box is made up of a kit of parts. We took everything to an upstream with it. But I will be honest, the one area that did let us down was the concrete base. We used a concrete base, and the process let us down there because we had to make a mold to pour the concrete. And for me, that took away of our idea of mass customization, because the process required repetition in the mold to make it efficient. So I spent a lot of time last year looking at how we could recreate the mold, how we could 3D print the mold, or how we could create even a better the mold or the actual base. So I wanted to really look at that and look at how the one-off could still be as cost effective. The economies of scale on one would be the same as everything else because of the process. The rest of the bathroom, we achieved that, but we never really got there with the concrete base. Still to this day, it still drives me crazy. I've had great ideas about how I can look at that and maybe even market and commoditize that in its own right. So what we did see though is we called that a multi-trade CDP. That was a bathroom pod that sat right in the middle. It was made up of all those multi-trades and those multi-elements, but we wanted to look at this and say, well, we could take this approach to the extreme with everything that makes up a building. And that was where the CDP, what we wanted to do was go out and find a network and build a network of available components, whether it was materials, single trade, multi-trade, the system as a structural system, or the full building. We wanted to actually create those kits of parts and then make them available so that really the typology, the building here on the far left, people could start to create that as a product, not just as a service. Architecture could be a product linked to a digital supply chain rather than the one-offs. So the business model there was, let's go and build components for free. So last year we decided, let's raise as much capital as we need to go out and digitize as much of the single trades, the material. Really where we did target was the multi-trade and single trade assemblies. If we went and built as many of those as CDPs as possible and put them on a marketplace, then we would have a new style of BIM component or a new ability for people to start to create systems and buildings with the digital supply chain and automate the process. So as we rolled that out, the idea of really collaboration, where we could go out and find the suppliers, design the components, but when we did that, those suppliers, we looked at their supply chain. We built in their supply chain. So the bathroom example, everybody that was contributing to building that bathroom became a part owner essentially of that CDP in its own right. They had to collaborate to create the process and the product at the first instance. So we leveraged technology there. The idea that we were building these components, whether it was a bathroom pod or a single family home frame with a light gauge steel frame, there was even a light gauge steel frame, although it was one supplier of the framing. It was a full supply chain of steel coil, the screws, fixings, the whole lot. So we leveraged the technology and we started to build those scripts. What we also started to build was the cloud infrastructure to hold that. With the idea that over that 5-year period when we were creating these scripts, we could catalog the nodes or the elements of those scripts and create an open source platform to enable anybody else to do this. Or that the bathroom pod in its own right could become a visual coding node so that people could start, other architects could leverage that exact digital component as well. But the one thing there is that we needed the marketplace, the cloud infrastructure. We needed to be able to package these scripts up, use a configurator on the front end and create a marketplace of configurators that would guide or give free use to anyone designing to these products. So we could restrict the design to what was achievable, and then we could automate the entire process. That marketplace then we saw as a huge potential to increase productivity across the industry, but also lower cost and risk. The more data that we could bring to the forefront and the more that we could empower architects and designers to design with these digital components or within the realm of what's achievable, the less risk and the less cost we could see. We could see that whole marketplace could drive efficiency through the entire industry. We could aggregate supply. We understood how many screws were going to be used on the East Coast of North America well ahead of time. We understood that if collectively, if all the users on that marketplace, all the CDPs listed on that marketplace came together, we could look at direct, not the layers of distribution in the construction industry, we could look at direct to manufacturer for screws, and we could collectively have a greater power. So as we started to take pre-registrations for Revea for this marketplace, we saw that we had over 780 architects registered straight away, design users rather than architects, and they collectively bought over $17 billion worth of work a year. That gave us the collective power there to be probably one of the largest general contractors, seen as one of the largest buyers or general contractors in the world. So that was one area that we started to see that this could really drive some change in the industry. Another area we saw was within contracts. We by controlling the payment and seeing things come through, we could actually de-risk it from a supply chain standpoint. The general contractor wasn't receiving the payment and have that chance of falling over along the line. It was if you were part of that group and part of that collaboration to create the component, you were tied to it. So far less risk and therefore you didn't have to have increased margins on the project. So that was where Revea came in. The Revea was the marketplace. We spent most of last year working through developing that. And with the idea here again of the customizable digital product being in the center of that we could take this group of people, they could all be product owners. We would list it on a marketplace. Revea was the marketplace for components. Now, how this worked is we built the cloud architecture where we could build those scripts and we could put them on there. Those scripts were stored in a database, and that database then enabled us to have all this knowledge data. So we could build the script down here, supply chain. We could load the component with as much knowledge as possible, all those constraints, all that, everything to automate the process. And then what we were able to do is through configurators and a plugin into Revit, bring that into the designers in the form of configurators where they receive that knowledge data. They received it in a way that they were guided through designing it, but they were also restricted to, again, to what was achievable. As they configured that, that direct data would come back up through that script and compute. And then because it was taking that direct loop back through and storing it in that script, that essentially we had every script became a template. And then every time a designer used that template, it would store that version of the script. It would store those inputs into the script and then compute it and send the exact output to the supply chain. It would send the direct machine files or the direct drawings. And so it took all this interpretation out of it, and it became a central source of data for that component and then for the project. Now, this diagram is a little bit more complex, and this explains what I just said in a little bit more depth. But what we created there was what we termed a 3-part marketplace, but it was essentially still a 4-part marketplace. So if you take Uber Eats or DoorDash or something like that into account here, we had essentially the architect was the driver. The architect would have free use of this platform where they could leverage their own infrastructure to create a better or offer a better service. Then you had the restaurants, which are essentially the group of product owners. They were designing the food there and then making that available in the marketplace. And then on the back end, you had the consumer. Now here we've got the product purchases as the consumer here, but where one area where we were a little bit different is we had this full supply chain that was linked into it as well. So let me walk you through this diagram a little bit. Input data, we'd load the scripts with as much data as we possibly can. And that full team would have the CDP designers, so the computational designer, manufacturers, assemblers, material suppliers, and consultants would all work, and you'll see here in the light blue, to load that script. That script would be hosted back onto the cloud, like I said, and then that data would maybe be made available through the marketplace where the architect would configure it and design it and feed the adjusted data back up into the script. That adjusted data would compute and wait for the product purchase, wait for the GC or developer or owner to lodge that procurement. They'd lodge that procurement, that would come through and it would go into a bank account. So they'd make that payment, that bank account would come all the way, would sit there and unlock the release of all the data to the supply chain. So as soon as that payment was made, the data would go directly to the people, not like traditional construction where that data would pass through many hands. It would go directly to the people that needed it. And then we could start to automate even the critical path for production. So the material suppliers would release, the data would be released to them and they would get a job saying, you need to create this on this date. And then that needs to be delivered to the manufacturer on this date, which then would come to the assemblers on this date. If one party let that down, we hadn't built this yet, but one area we were looking at, if one party let that down and rejected that, it would automatically recreate a new critical path. It would automatically send the new dates out and schedule. This is where it became super exciting for us to look to the future where machines would maybe be IoT, we could control, you could actually really control outside of infrastructure or supply chains infrastructure without owning it, which then completely challenged this idea of vertically integrated to control the process. But what it did allow was this idea of a decentralized supply chain and localized assembly that we'd shown with the bathroom pods being taken to an absolute extreme. So the future Splash Modular, this is a little bit, this is an old image here, but the idea that it was a Revit plugin, the configurator there, a step-by-step guide to designing for that bathroom pod, but we were able to then give real data insights into the completion level and then the cost. So you'd start off and the bathroom configurator work that you would draw an outside the curve of how big you wanted the bathroom. And then it would give you a price point. It would say this bathroom based off this size and the decisions you have to make is going to be between $5,000 and $15,000. And then as you work through this step by step and your completion level came up and you answered those questions or you configured it, the price point would come down to an exact. And that it was an exact that was given to the architect at that time so they could design to it a budget. And then it really didn't have any changes because everything was a known entity. Because at that same time that we were doing this, we were understanding how long it was going to be on a CNC to cut the drywall. We understood that exactly how many elements were going to be used, the exact bill of materials, logistics, everything was a known entity. So that was the idea there behind Revea. And it just so happened that 3 weeks ago now, we were acquired. We were getting ready to launch Revea at the end of the first quarter here. We huge uptake of people waiting for it. We're building many scripts for people right now, but we've just been bought by a company called Onyx.ai. They are going through some branding process right now with that. They're a startup out of Silicon Valley, backed by some very interesting people in the industry and a great team. They've built a great team of ex-Autodesk here, ex-Katira, ex-big data and machine learning and artificial intelligence. So what we are part of this now is we're essentially creating that industrialized construction, all these configurators, which form part of something much bigger, which is a decision engine for all stakeholders through the construction lifecycle, the ways of construction. So if construction currently is, we're working off a 2D map with point A and point B, and we're trying to find our path through it and tripping over and crashing into things while we're trying to look at the map, then what we're creating here is ways. It's data insights and decision centers. So it's going to foresee issues coming up and help guide all stakeholders through it. But you can see that what we create here is we've actually that front end and that design. So we're actually through the configurators and taking all that knowledge of downstream of the supply chain, we're able to give the designer much more power, but also give them the ability to make the right decisions in the design, understanding the implications of that through the life cycle. Even with carbon ratings and all sorts of things like that. So